Welcome back, students. So most of the students often confuse with reactions of benzoic acid. But what if I tell you that there are three most important reactions are there for benzoic acid? Just by learning these three reactions, you can easily score 5 out of 5 marks in your final examinations. So in this video, I'll be explaining those three important reactions, that is salt formation, conversion to functional derivatives, and then finally ring substitution reactions of benzoic acid. So stay with me till the end of this video. Now let's jump into the topic. The major reactions of benzoic acid are salt formation, conversion into functional derivatives, and ring substitution reactions. Now let us discuss these reactions one by one. So the first important reaction is salt formation reaction. Because carboxylic acids are having acidic protons, they can be treated with aqueous alkalis such as sodium hydroxide or potassium hydroxide, so that they will be giving corresponding salt. So when benzoic acid reacts with sodium hydroxide, there will be formation of sodium benzoate salt. Benzoic acid is usually water insoluble, as I mentioned earlier, but the salts which are obtained from the benzoic acid, that is sodium benzoate, is water soluble in nature. Now, the formed salts, upon treating with mineral acids, that is either with hydrochloric acid or sulfuric acid, they will be converted back to corresponding benzoic acid. So, the salt formation reaction, as I mentioned, even under phenols also, it is a reversible reaction depending on the favorable conditions. If the amounts of alkali are predominant, then there will be formation of more and more salts. Okay. On the other hand, whenever there is predominant amounts of mineral acids are available, then the reversible reaction occurs, and immediately as soon as the salt formed, immediately it will give corresponding acid. So this is the first important reaction of aromatic carboxylic acid. The next important reaction of carboxylic acids is conversion to functional derivatives. That means these aromatic carboxylic acids can be converted to their functional derivatives such as acyl chlorides, esters, and amides. Now let us consider one example under each class. So the first reaction here is conversion of acid to acid chloride. That means benzoic acid will be converted to benzoyl chloride, which is an example for acid chloride, by treating benzoic acid with phosphorus pentachloride at 100 degrees. So here carboxylic group will be replaced with COCl group. That is how corresponding acid chloride will be formed. And in this reaction, phosphorus oxychloride, POCl3, is known as phosphorus oxychloride, and hydrochloric acid will be formed as byproducts. The next reaction is esterification reaction, where benzoic acid is treated with methanol in the presence of an acid, and it gives corresponding methyl benzoate as the product. In this, acid group is replaced with an ester group. COOCH3 is the methyl ester. So the third reaction is conversion of carboxylic acids to amides. So in this reaction, benzoic acid is heated along with ammonia. Then carboxylic group will be converted to amide group. CONH2 group is an amide group. And that is how benzoic acid will be converted to give corresponding benzamide. So in these reactions, if you observe, the carboxylic acid group is converted to acid chloride, ester, and amide. That is why this is known as conversion of acids to functional derivatives. So if you look at the first reaction, the OH group will be replaced with Cl group. That is how acid gets converted to acid chloride. Now in the second reaction, if you see, the OH group is replaced with methoxy group. Okay, so here OH will be replaced with methoxy group. That is how finally we get corresponding ester. In the third reaction, where amide is formed, the OH group is replaced with amino group. That is how we get corresponding amide. The third important reactions of benzoic acid or aromatic carboxylic acids are known as ring substitution reactions. So aromatic carboxylic acids will undergo ring substitution reactions mainly due to the presence of this benzene ring system or aromatic ring system in their structures. So these reactions are very much similar to that of electrophilic substitution reactions of benzene, which were discussed under module 1. Okay. As there we have discussed under reactivity and orientation. So here benzene ring system is already containing carboxylic group. As I mentioned earlier, the group which is already present on the benzene ring system is important, and it is this group which determines the orientation of the next incoming electrophile on this aromatic ring system. So there we have considered that carboxylic group is a meta-director. That means whatever may be the electrophilic substitution reaction that you perform, the formed electrophile will attack only at meta position. Okay, so let us consider an example for that. So when benzoic acid is subjected for nitration, that is when it is treated with concentrated sulfuric acid and concentrated nitric acid, there will be generation of nitronium ion as the electrophile. Now, the liberated nitronium ion, it prefers to attack at meta position, and thus nitro group will be attached at the meta position, and thus results in the formation of meta-nitrobenzoic acid as the product. Now, in addition to this, you can consider any other reactions like sulphonation or halogenation, Friedel-Crafts reactions as discussed under electrophilic substitution reactions of benzene. Only one thing is, in the product, write the structure of benzoic acid and whatever may be the corresponding reaction, the generated electrophile attach at the meta position. Okay, so that we get corresponding meta substituted derivative. Coming to the reactivity of this particular benzoic acid towards the aromatic electrophilic substitution reactions when compared with reactions of benzene, we have already discussed under theory of reactivity under monosubstituted benzene that carboxylic acid group is a deactivator. Okay, that is the reason even though benzoic acid undergoes electrophilic substitution reactions, because it is a deactivating group, these ring substitution reactions of benzoic acid are somewhat slow when compared with electrophilic substitution reactions of benzene or toluene. So these are the three major principal reactions of aromatic carboxylic acid, or you can consider them as benzoic acid reactions also, because mostly in the final examination you are getting the questions such as write the important reactions of benzoic acid. So if you look at all these reactions, we have taken benzoic acid as the starting compound. That means you can consider the same to answer that particular question. So the three reactions which I mentioned are salt formation reaction, and then conversion to functional derivatives, and then finally ring substitution reactions. So these are if this video is useful to you, then give it a like, subscribe my channel so that you won't miss the next important chemistry concepts. Also, check the link given in the description to access a free course on mastering benzene. Thanks for watching. I'll catch you in my next video.